So if you look at your chart about squares and parallelograms, a square is a special parallelogram. Um, the opposite sides opposite sides and angles are congruent, right? However, a square has sides and angles congruent. Also, a square has congruent diagonals. Diagonal. While a parallelogram does not. Ooh, did I spell parallelogram wrong? Spelled it right earlier. Okay, there we go. Okay, do you see how to answer those questions? Now, they don't have to be exactly the same as what I wrote because you could have chose different properties. You use the chart that we filled out about the yes and no's, right? Like squares and parallelograms, they're both four-sided figures. Squares and parallelograms, they all have to have a sum of angles of 360, right? So you would use that chart because I will probably throw one of these on the test. And the only reason I do that is because I know that the TABE test, if you go to work one, has one of these questions on the TABE test, unless they changed it, which I don't think they have. And that should have like that. Okay? Any questions on that one? No? Okay, so here we're just naming the most specific name for the figure, right? So what's this one called? Oh, we're going to go to draw. Oh, I guess I could type it because that way you can read it a little bit better. This one's a trapezoid. What about this one over here? That one's a rectangle. You know that it's not a square because square would have all four sides equal and four right angles. The reason why this is a rectangle is the opposite sides are equal with four right angles. Okay? Make sense? Okay, so trapezoid, I wonder if I can, oh, let me put it right underneath it. Trapezoids only have one pair of parallel parallel sides, where a parallelogram, squares, rectangles have two pairs of parallel sides. So see how this is only the opposite, only one pair is opposite? These two are not parallel. So that's what makes it a trapezoid. Good? Okay. Now what's this one? This one's a kite. And what about this one? That's a rhombus. A kite, two adjacent sides are equal, not the opposite sides. Okay? That's what, can I move this? Yeah, I can move this. Okay, that's why this is a kite, because see, the ones that are next to each other are equal, not the opposite. See here, a rectangle, the opposite are equal. That's the difference with a kite. And then of course this is a rhombus. Oop. All four sides are equal, but the angles are not equal. So the angles are not 90 degrees. That's why it's not a square. The square would have shown all four equal, right? Four angles and sides. So you would have saw four right angles if it was a square. Any other questions on those? And then what's this one? That one's parallelogram. Opposite sides are parallel. And you have two pairs, where a trapezoid only has one pair. Pair means two. Is that helpful? Okay. Where is everybody today? You know, that happens a lot in adult ed. It's like they think they can just take off an extra day or be late. And it's like you lose so much instruction because now I got to get caught up on the day that we missed.
Well, maybe it's like with my family, maybe some of their family for Memorial's out.
Oh, well, and there are a lot of plane flights that have been delayed or canceled. Okay, so now we're here, right? Now I have to draw. I have four angles, right? And it's asking for the angle measure of angle V. To find angle V, though, I need to find X first. Does everybody agree with that? To do that, I need to know what the sum of all four angles would be. What would all four angles have to add up to if it is a quadrilateral? 360 degrees. Remember, we talked about that with properties of quadrilaterals. It was on your little checklist that all of them, no matter what, had 360 degrees as their total. And we're going to be working more with interior angles today. So we would write this as 8x minus 4 plus 12x minus 2 plus 116. And a lot of people forget this last number. This box means a number. What number does this box mean? 90 degrees. Don't forget the 90. So many students do that. And then that's 360 degrees. Now I'm going to add my x's together and add the constants. 12x plus 8x is 20x. A negative 4 and a negative 2 is a negative 6. A negative 6 plus 116 is 110. 110 plus 90 is what, 200? Someone wants to check that with the calculator, make sure I did that all right. Did I do that correctly? It is, Ella? Thank you very much for doing that for me. Okay, I'm going to subtract 200 on both sides. When I subtract 200, I get 20x is equal to 160. I'm dividing by 20 on both sides. And x is equal to 8. Am I done? No, I'm not done because it asked for the measure of angle V. So the measure of angle V would equal 12 times 8 minus 2. which this is 96 minus 2 is 94 degrees. So if you forget this last step on a test, then I have to take off points because it's asking for angle V. Just be careful. Okay, so then over here, I'm going to do the same thing. I have 10x plus 4 plus 16x plus 9 plus 96 plus 95. Boy, that's an awful lot. Has to equal 360. You need to combine your like terms first. So 16x and 10x is 26x. And now I'm going to add all of those numbers together. I have 4 plus 9 plus 96 plus 95. And that's 204. 204 equals 360. I'm subtracting 204 and 360. So 360 minus 204 is equal, I forgot. I put his point. Sorry, I was distracted there. 360 minus 204 is 156. So 26x equals 156. And now I'm going to divide 156 by 26. And when I do that, I get x is equal to 6. But it doesn't want just x, it wants the measure of angle C. So I'm going to look for where angle C is, which is right here. So that's going to equal 16x plus 9. 16 times 6 plus 9 will give us the measure of angle C. So 16 times 6. And that is 105 degrees. Two answers. Answer for x and then substitute it in. Now we're filling up a little bit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We're still missing 9 people. Eek. Okay, so I'm going to have you do number 9 real quick. Make sure you can get the right answer there. Yes. Okay, everybody do number 9. Well, I'm trying to put it so I can squeeze it all on there. There. You good? So when you get the answer for 9, raise your hand and I'll check your work real quick. Okay. So yes, this answer should have been, where did my pen go now? It fell. You should have got x is equal to 2, and the measure of angle W is equal to 108 degrees. Okay? So now this one. Be careful on these. Position matters. Okay? These are parallelograms. And in parallelograms, the opposite angles are equal. The adjacent or consecutive ones have to be supplementary. So these are equal. These you add together and set equal to 180. Do you see the difference? Yes, don't mess those up on the test. You may want to write a note to yourself. Opposite angles are equal. Consecutive or adjacent. Consecutive or adjacent, meaning they're next to each other, are supplementary, which means sum of 180 degrees, right? So these two, I would just say, oh, 28x minus 5 has to equal 27x. You want to make sure you're separating the variable and the constant. So you get negative 5 equals negative 1x. Divide by negative 1. X is equal to 5. Once I get 5, I want to substitute back in. And when I substitute in, because I have to find the measure of angle W is equal to 27 times X, 27 times 5, which is equal to what? 135? Is that true? 135 degrees. Okay. So next one, we're going to add together and set equal to 180. So 7x plus 15 plus 9x plus 5 has to equal what? 180. Because they are consecutive. So 16x plus 20 has to equal 180. I subtract 20 from both sides. 16x is equal to 160. X is equal to 10. It asks for the measure of angle U, which is equal to 7 times 10 plus 15, which is 85 degrees. So the two setups are different, right? And that's the key with geometry, knowing the setups. Okay. Okay, so now we're going into our area, right? We learned about area, and we have to be careful because if I notice here, what do I notice about my units? They're not the same. You have to get the same units before you calculate area. You have to do conversions. Now, when you're doing conversions, remember that I put a chart in your notes, and you're allowed to use those notes for your test. You can set up ratios to figure out the conversions. So here, first of all, I need to know what type of figure this is. What figure is this? That's a parallelogram. And what is the area formula for a parallelogram? Area is equal to base times height, where the height has to be where there's a 90-degree angle. See here how it's drawn at a 90-degree angle? This is base, and then this is height. Sorry. And this is base because this is where it's drawn to. I don't need these extra information over here. Okay? So they threw in extra information. You don't need to use those. But now I have to do conversions. For CUDA software, they always convert to the larger unit. I know that 1 centimeter is equal to 120 millimeters, right? If I have 1 centimeter does not equal 120. It equals 10 centimeters or millimeters. Sorry. I want to find out how many centimeters 120 millimeters are. Notice I have centimeter on top, so centimeters on top. I have millimeters on bottom, so millimeters need to be on bottom. And then you are cross multiplying to figure it out. This will tell you if you're multiplying or dividing, basically. So 1 centimeter times 120 is 120. And then this is 10 millimeters times x centimeters. This would be centimeters, millimeters. So when I divide by 10 millimeters, these cancel and the millimeters cancel. You're left with 12 centimeters, right? So this, instead of 120, this is going to be 12, right? Any questions on that so far? Now that they're both centimeters, now I can figure out area. I substitute in area is equal to 9.2 times 12. And of course, this is centimeters, which means I'm going to have centimeters squared. Area equals, what is 12 times 9.2? What did you get? 104? Oh, 110.4 centimeters squared. Okay, makes sense or doesn't make sense? Okay, so here, what shape is this? It's a trapezoid. If you don't know your shapes, it's pretty hard to figure out what formula to use, right?
Yes.
So this would be areas equal to Base 1 plus base 2 times height divided by 2. The reason why this is a trapezoid is these two sides are parallel, meaning they're heading in the same direction, but these other two are not. This was a parallelogram because these two are parallel and these two are parallel. You don't count the dashed lines as part of the figure. It's just measuring a height. So, base 1, base 2, and height. However, this is in yards and these are in feet. And according, yes. Huh? Oh, go ahead. Yes. You're going to divide both those by 3 because when you're going from a smaller unit to a larger unit, you always divide. If you're going from a larger unit to a smaller unit, you're going to multiply because you're getting more. Okay, so here you divide both of these by 3. You don't know whether you multiply or divide, you can set up the proportion. Proportions will always tell you if you're multiplying or dividing. If I know 1 yard, is equal to 3 feet, and I'm converting to yards, you would cross multiply and you would end up dividing by 3. So what is 32.7 divided by 3? So this is 10.9 yards. And then what's 12.9 divided by 3? 4.3 yards. Now I can do area because I'm all in yards. Area equals base 1 is 10.9 yards. Base 2 is 4.3 yards. Height is 10, and I still have to divide this by 2. Now, if you don't use your parentheses, make sure you're pressing equal before you multiply by 10. I noticed some people were getting wrong answers. You could do it like this, but in your parentheses, 10.9 plus 4.3 parenthesis times 10. Press enter and then divide by 2. And that'd be 76 what? Yards squared. Very good. Well, this doesn't do justice for you because CUDA it just assumes you're going to be converting to the largest unit. If you had like a word problem, or in real life, if you were buying carpet in square yards and you measured in square feet, you'd know you'd have to convert it. Does that make sense? Okay. So here, what shape is this? Triangle. And what's the area formula for a triangle? A equals base times height divided by 2, where your base and height is where your right angle is. So this would be the height, this would be the base. You're going to divide by 10 to change this to centimeters. So this would be 5 centimeters. So this would be 6.5 times 5 divided by 2. 16.25 centimeters squared. And this is just done the same way, except for this is meters and centimeters. You would divide by 100 to convert centimeters to meters. So this would be 2 meters. So you would have height and base. Again, area equals base times height divided by 2. So this would be 2 times 4.7 divided by 2. The 2's cancel. So that's 4.7 meters squared. I like it when I don't have to use a calculator. This is a longer do now because we had the extra break. So I wanted to make sure we were reviewing everything. I hope you appreciate that I'm doing a review from everything from last week. Okay, in this case, we're given area and we have to solve for a side length. So what shape is this again? Triangle. So area equals base times height divided by 2. In this case, we're given the height. We're looking for the base, but we have the area. So you do 30.2 inches squared is equal to x times 5.7 inches divided by 2. You can multiply by 2 on both sides to clear the fraction, and you would get, what, 60.4 is equal to, and I'm just going to put the coefficient in front, and this is inches squared, and this is inches, and this is x. You divide by 5.7. And what do we get when we divide by 5.7? What does x equal? What was it? 10.6? Oh, let's see. You had like a little inflection. Was it because you had to round? I'm going to guess. Oh, yeah, it'd be about 10.6. And that would be inches. So 10.6 inches. And the reason why it's inches, see how up here we divided by inches squared by inches? You subtract those exponents if you remember from Algebra 1B. So that's why now it's just inches. Which if you take ICP in the physics part, you have to know how to cancel your units properly. Okay, now centimeters. What type of shape is this? That's parallelogram. So area equals base times height, where this is the height and this is the base. So 16.2 centimeters squared has to equal 6 times h, and this would be centimeters. So divide by 6 centimeters. And what do we get for our answer for our height then? What is it? 2.7 centimeters. Oop. Got one more and then we're done with the review. Look at that. I nailed the timing pretty close. Okay, so again, what kind of shape is this one? It's a parallelogram again. So area equals base times height. Area is 12.8 centimeters squared. This is my height. This is my base. So x times 3.2 centimeters. So just divide by 3.2 centimeters on both sides. And then you should be able to solve. And what is 12.8 divided by 3.2? 4 centimeters. Okay. So today we're going to talk about angles, and then we're going to talk about symmetry and rotational symmetry, all this fun stuff. So that way we can understand how to find area of regular polygons. So let me go ahead and, okay, so on the sheet that I just handed out, right, it has a chart that you're going to fill out. And the first one, we have a triangle, right? And how many sides does a triangle have? So, on the chart where it says number of sides, right? You will put 3. And then it says number of triangles. Well, it's only one triangle, right? You only see one triangle? And you'd put 1. And then down here it says sum of the interior angles, right? Well, you know this. We've worked on this. What is the sum of all 3 of these angles? It's always 180 because we're talking about a triangle. So this should be 180. Now let's look, and they had a rectangle, right? What the heck is that? Oh, that's someone's. Oh my. Okay, to do this one from one vertex, only one. Students make mistakes because then they start going crazy and they go from many vertexes. When I say vertex, that's a corner, and you're only going to go from one. You're going to draw all the diagonals from one corner. Now, in this case, that's all I can draw because I can't draw here and I can't draw here. There's only one diagonal from this corner, right? Do you see that? So, if I'm doing this one, how many sides do I have? No, sides, outside. 4. I have 4 sides. How many triangles do you see? And 2 times 180 is what? 360, right? Okay, the next one they have is a pentagon. I'm just going to help you with drawing the, isn't that cool that it does that for me? Love it. Okay, so I'm going to go here and I'm going to draw my diagonals. I'm going to pick one vertice, just one, and I'm going to draw. So I can draw to here, right? And I can draw and I can draw to here. Can't draw to the ones next to each other because that's just going to be, that would be that side. How many triangles do you see? Okay, now you start filling out the chart, and I want you to see if you can figure out what the formula is for finding the sum of interior angles. Work at your tables, see if you can use your inductive reasoning skills to figure out this formula. Okay, so after doing this exercise, what was the final end? What was the interior angle formula? What did you get? What did you get for your interior angle formula at the bottom? What was the last formula? At n minus 2, no negative 2, n minus 2 times what? 180. Oh, I don't know why it put me way over there. Times 180. Okay, so now we're going to head into our notes. Hmm? As long as you fill out the chart, that's all I care about. Okay, so let me go ahead and um, take a look at this chart about the names of all the polygons while I'm erasing these. Okay, so take a look at your notes, look over the chart, see if you know them. Do you have an extra one of those for me, Israel? Thank you. Okay, so first of all, a polygon. A polygon is a closed plane figure with at least three sides that are segments. It has to be enclosed and they can't cross over. See here how the sides crossed over on the inside? This is not a polygon. This is not a polygon. But this is a polygon. Now, you can name a polygon by its vertices. You can start at one point, one vertice, and just go around in a circle. You can't cross over. You can't tell me A, D, E, C, and then B. You can't do that. You have to go around. You can start anywhere. Like I could start at C and I could go C, D, E, A, B. But you have to go around. Or I could go C, B, A, E, D. Does that make sense? You have to go in order. So right here, do you see three polygons? You see the trapezoid. I think that's a trapezoid. You see a triangle, and then you see a pentagon, right? So let's name each of these. First of all, what would you name the triangle? No, it has to have, what's the name? L, and we put a little triangle, L, M, N. Okay, how about the quadrilateral? I really don't know if it is a parallelogram, so I'm going to just call it quadrilateral, which means four-sided, right? How am I going to label this four-sided figure? Someone? Just go. L P O N, right? L P O N. If you started at L, you just had to go in order. I could also call it L N O P if I decided to go this way with it. How about the pentagon? which means five-sided. How would I label this one? If I start at L again, what would I do? L, M, N, O, P. Someone started doing this, L, P, O, and M. That would also work, as long as you're going around in order. Okay, so here's the chart. You're going to have to know these. I can let you use this for your test, but you need to know these. A triangle is three-sided. A quadrilateral is four-sided. A pentagon has five sides. A hexagon has six sides. Heptagon is seven sides. Some books call it septagon. Yeah, some books will call it septagon or heptagon. Um, number 8 is octagon. Number 9 is nonagon. 10 is decagon. 12 is dodecagon. Any other numbers, you use the number with a gon next to it. So notice that it didn't have 11, right? So you would write 11 gon. If it was 100-sided, you'd do 100 gon. Okay? That's how you would do that. Any questions on that one? I think you have, let's look at our template here. We definitely have triangles. We definitely have quadrilaterals. What numbers are pentagons? Uh, no, 5 is not a pentagon. 4 and 9 are pentagons, as long as you have to have a blue one, not a green one. So do you see 4 and 9 are pentagons? Okay. Hexagon is 6. 1, 2, 3, 4, 5, 6. What number is six-sided? Number 5 on our little template here is a hexagon. Do we have a seven-sided one? I don't know if we have a seven-sided one. 1, 2, 3, 4, 5. Oh, 24, I think, is a seven-sided one. 1, 2, 3, 4, 5, 6, 7. Yeah. Yeah. Number 24 is a seven-sided figure. It's a heptagon. Okay, where's the octagon? Number 10 is an octagon. 1, 2, 3, 4, 5, 6, 7, 8. Yep. 1, 2, 3, 4, 5, 6, 7. Okay, do we have a nonagon? 23 is a nonagon. Yep. Do we have a decagon? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. Number 14 is your decagon. Do we have a dodecagon? I don't think we. No, we don't have a dodecagon. So dodecagon is 12-sided. Okay? So we have all of them but the dodecagon. Okay. Convex versus concave. Convex means all the corners are pointing out. Cave means that you have like a dent, a cave in. I have a pretty new car. I'd be sad if it had a dent in it. I gave my son, when he graduated college, my car, which was only like 5 years old. It didn't have a whole lot of miles on it. And within 2 months, he had a nice big dent in the car, which would be concave at that point. So concave means you have pushed in like a cave. You don't have that one on there? Well, you want to write this on here because you need to know the difference. So maybe on the back or somewhere. Is there any space? Or a sheet of paper. Think 3 and 4 over here. 3 and 4 has you on the back. You could write the definition right under those two because those are the questions if they're concave or they're both concave. But to write it there. Okay, tap my. Okay, so does everybody have these written down? No, they do not have one that's caved. No. I have the electric one. Okay, so classify. So right here, it's asking to classify these. They gave the answers on the bottom, but let me tell you how they got the answers. It said classify each polygon by its sides and identify if it's convex or concave. So here, I would count the number of sides. 1, 2, 3, 4, 5, 6. And I would say, oh, it's 6 sides, which makes it a hexagon. All the corners are pointing outward, so it is convex. Over here, I'd count the number of sides. 1, 2, 3, 4, 5, 6, 7, 8. So that's why it is an octagon, because 8-sided is octagon, like octopus. Octa means 8. And it's concave because see here how it's pushed in? And it's pushed in over here. Anytime it's pushed in, like there's a cave, that's why it's concave. Makes sense or doesn't make sense? Makes sense. Now you already did this next slide, but we'll quickly go over it. Gonna skip that one. Okay, we did this. That's what you were doing, right? How did I have when I had 4 sides? 2. And what was the amount of degrees? 360. Right? When I had 5 sides, how many triangles did I have? 3. And 3 times 180 was 540. When I had 6 sides, I had how many triangles? 4. And 4 times 180 is 720. And from this pattern, we figured out the formula. The number of triangles would be the number of sides minus 2. And then I multiply this times 180. This is called the sum of interior angle formula. That's what that's called. Sum of interior angle formula. So, I think did I change this number on here? That's why I wanted to peek at this. Okay, find the sum of the measure of the angles of a 15-gon. Well, how many sides does a 15-gon have? What is it? 15. So we would substitute 15 into the formula. 15 minus 2 times 180, which is equal to what? What's 15 minus 2? 13 times 180. What is it? 2,000 degrees. So if it's right here, right there. I think you're on the wrong sheet. Nope, wrong sheet still. Flip it over. There you go. It's okay. We good? So when you get the number of sides, you substitute it in. You subtract 2. Press equal if you're not using a parentheses. Then multiply by 180. Now this one changed on our notes because our notes had a different one. It said 2700. Okay, yours says that. Mine here did not. Okay, here it says the sum of the measure of the angles of the given polygon is 2,700. How many sides does the polygon have? So in this case, I would do n minus 2 times 180 is equal to 2,700. I would divide by 180 on both sides. So 2,700 divided by 180 is what? 15, right? So this cancels here. N minus 2 equals 15. What would I do to both sides to solve for n? I have to add 2. Add 2. So the number of sides is equal to 17. Okay, so then this next one, find the measure of angle Y. Does this one have this one? No, no, you don't have that one. Have this one. Okay. Well, I try to keep it to one page because every time I have to add a second page, that's like 25 sheets of paper for this class. When it's my algebra classes, that's over 45 pieces of paper for each paper. So I try to keep it at one paper if I can. I can't all the time, but I'm trying to save us some money. Okay, So pentagon ABCDE has 5 congruent angles. Find the measure of each angle. Well, since they are congruent, we'll be able to find what each angle is by division. But first I have to find the sum. So I'm going to do 5 minus 2 times 180, which is 3 times 180, which is equal to what? 540. Now, this is the sum, but I just said that it has 5 congruent angles, right? If it has 5 congruent angles, then I would divide this by 5. And that is equal to 108 degrees. So the pentagon would have each angle being 108 degrees. Now, did I have something there talking about regular? Okay, so this is another terminology you need to write down. Regular polygon. When it says regular, that means each side and angle have the same measure. Okay? When I call something regular, that means that each side and angle are the same. So when we were pointing out the polygons on our template, they are regular because they are marked that each of the sides are the same. So number 2 is a regular triangle or equilateral. 3 is a square, which is a regular polygon. 4 is 4 and 9 are regular pentagons, right? 5 was a regular hexagon. Look at your pictures. 10 was a regular octagon. We did have a 7-gon, which is a heptagon. 24 is regular. All of those would be that you have the same sides and the same angle measures when they are called regular. Okay, any questions about that? Exterior angles. Take a minute right here and add each of these angles together and tell me what the sum is for figure 1, 2, and 3. Go ahead and use your calculator quickly and just add up those angles that are on the outside, the exteriors. Figure 1, 2, and 3. They're all 360. Okay, so the theorem, and it's in your notes, the sum of one set of exterior angles for any polygon is 360. Now, if it's a regular polygon, I'm going to add to this. If it is regular, what does regular mean? All the exterior angles, the interior angles, and the sides are going to be the same. if the polygon is regular, the individual is 360 divided by n, where n is the number of sides. So I'm going, and then there's these here for, well, did I have this in here? No, it didn't, it wasn't in there. Okay, so for some reason, it doesn't have the practice for you. Go ahead and do 1, 2, 3, and 4. I'll go over those answers with you. It says find the measure of the exterior angle in each regular polygon. Round to the nearest tenth if necessary. So number 1, how many sides is that? 11. So to find this answer, write 360 divided by 11 because it's regular. So what's 360? You're going to have to round it probably. It'd be 32.7 is what I would round it to. And what about the next one? How many sides is that one? So it'd be 360 divided by 6. And 360 divided by 6 is 60. And number 3 and 4, are both those concave or convex? They're both concave. Yep. I even told you they were going to have the same.